Good afternoon, Sean here from Mountains Garage. It's Monday, working in the shop. It's a beautiful day. It's been about a week since I posted a video, and I got just a bunch of random stuff, so this will be another shop life video. I'm going to call it three-phase power, because we'll get into that in a minute, briefly. First, let's go over some random stuff that happened this week. A couple months ago, I mentioned I bought a ring and pinion made by a manufactured by a company called Elite, or at least sold by a company called Elite Performance, or Elite Ring and Pinion. I don't know, I have to look at the box. And in the box was a piece of paper that suggested, they gave you, said, for this application, use this shim. Never seen anything like it before in my life. And I think it's great. It's been a long time shrouded in secrecy. If you probably knew the truth, if you work for a major ring and pinion place, they probably know this. This is common knowledge that they're all made off of master dimension, run on a machine. They already know what shim it takes. They just don't tell you. I don't know the whole story. I'm not talking about ring and pinions today. So then, last week, I'm doing another Turbo 400, and I bought one gasket set from, I'm not a paid spokesman, but Phoenix Transmission. It was pretty expensive, but I needed it right away. It was like $36 for just a gasket and seal kit. It wasn't just a paper and rubber kit. This is my average paper and rubber kit. It's made by Precision. I buy these in bulk, like $17.50 a piece. I paid $36 for this other one, but it had the seals, the hard seals, front and rear. That's about the only difference between a paper and rubber kit or a gasket set and a seal and gasket set. And this one was made by Toledo. I swear I don't work for any of these companies. I'm just telling you where I got it. This was on eBay, Phoenix Transmission, $36. Hell of a kit. It actually came with Teflon seals and metal sealing rings, which is cool. So it's a step up from my standard $17.50 one. But wait, this blew my mind. Now, I've been doing transmissions since I was a teenager. And when you open the gasket set, there's all your lip seals that are thrown in a pile. And you're supposed to figure out where they go. They have little part numbers on them. If you want to do it that way, you can do it by size. It's not that hard in at least a Turbo 400. You're probably not going to get them wrong. I open up this gasket set. Each one's individually wrapped with a picture of where it goes and how it goes together. I felt like I was on vacation. I could just open a package and pull out the right stuff. I don't care how long you've been doing it. I think I'll pay extra. Whoop, that one's got nothing on it, but it tells you forward and direct drum, and there's a picture of how it goes together. It doesn't tell you what to leave out, but you're supposed to know that. But imagine that, individually wrapped with pictures, actual pictures of how it goes together. Now that's cool. Long before I was rebuilding transmissions, I worked in 2 transmission shops, and when you started in a transmission shop, you were the R&R guy. You remove and replace. And you do some minor troubleshooting, service work, but you get pretty good, especially if you're into the car hobby, about what fits, or what will replace what. Now, if you go online, there's lots of charts that'll tell you the different lengths of transmissions and the crossmember mounting. Overall length, it's great information for swapping. I got most of it in my head. I've done a lot of transmission swapping, but sometimes you forget. So I was helping a friend convert from a short shaft TH350 to a short shaft Turbo 400 in his 70 Nova. I think it's a 70. And he actually bought from Ground Up SS396 Ground Up Restoration. He bought the Turbo 400 crossmember, but with a Nova and first gen Camaro, third gen Nova, first gen Camaro. The only way you could get a Turbo 400 was with a big block. When they put a big block in those cars, they offset it to the passenger side 1 inch. So your Turbo 400 crossmember, the actual bracket is going to be offset 1 inch. You got to know that. You can get by. There's ways to adapt. In this case, he actually used a single stud mount just through one side hole and did not modify the crossmember at all, and it all bolted right up. And the single stud mount, even if you buy a polyurethane aftermarket mount, it's got the 2 holes and it's got the 1 hole, so you can make that work. But that's not what I'm talking about today. I'm talking about me being forgetful. So I'm thinking, and that cross member online for he bought was like $60, $59. I mean, that's a pretty good deal. I probably can't fab one for that, especially having to bend the humps and everything to clear the exhaust. You know, it's probably a half a day project anyway. And here's one all powder coated for $59. So I'm thinking, I should pick one of those up. And then it hits me. I bought 2 Novas 3 years ago. One previously had been swapped a 204i, which didn't come with the car, but the crossmember did. It's right here. And I'm sitting in there in my chair thinking, wait a minute, 204i and a Turbo 400 are the same length and the same rear mount location. The only two that share it. All the others, Saginaw 3-speed, 4-speed, Muncie 4-speed, T10, Power Glide, TH350, they all take the same crossmember location from the back of the engine to the bolts on the mount. They're all the same. The only one that's different is Turbo 400 and then eventually 204i. And then when you get into 700 and stuff like that, that's completely different. So I'm sitting there thinking, wait, I have somewhere, it came with that Nova, a 204i crossmember. In one of my Novas, I'm going to put a Turbo 400 in it. I was going to spend $60 for this, nice reproduction of a GM Turbo 400 crossmember. And I got it right here. Now, what I don't know until I do measuring or get it in the cars, if they knew or even cared, because in this case, you're putting a 204i behind something, it's probably not a big block. It's probably not offset an inch to the right. We'll see. I'll keep you tuned, but this was my find today. I was actually doing some cleaning at 6 o'clock this morning, and I came across that crossmember. And it might have made my day. And finally, to get on the topic of the headline, 3-phase power and you. Now, I live on a dead end off a dead end. And if you look at the top of your telephone pole, there's one wire up there. If you look at the top of your telephone pole in your neighborhood and there's 3 wires, you have 3-phase power available. I have 1 wire. I have single-phase power available. I'd have to go 3 miles down the road before I see 3 wires up on top of the pole. That's how you know if it's available in your neighborhood. So a few years ago, and many years leading up to that, sidebar and a disclaimer, I'm not an electrician. I know just enough to be dangerous. I wired everything you see in my shop. I'm still alive talking to you. That's all I can tell you. So don't do as I do, I guess. Figure it out for yourself. But I'm going to talk about it, and you can make an adult decision on your own whether you think you can handle it. It's not that hard. There's a lot to know. All right, back on subject. So many years leading up to the point where I actually got the mill that's always in the background of most of my photos, I saw lots of 3-phase powered equipment for sale, and I always just wrote it off because I know I don't have it. I don't know how to get it. What good's that piece of equipment going to do? I'd have to try to convert the motor over, which is not easy and probably very expensive. You see a lot of 3-phase equipment for sale, pretty reasonable for this reason, because most people think they can't use it at home. So I was offered the mill. I made a good trade for it. I'm going to pick up this crossmember one more time. I wanted to be able to make an oval hole. I had pretty low expectations, but just the thought of being able to make a hole that's oval without using a grinder would be pretty cool. So I dragged it home and then did a little research and decided that mine was, Bridgeport is the most famous mill there probably ever was, built in Bridgeport, Connecticut. They typically have a 1 or a 1.5 horsepower motor on them. My Clausing Condia was a CNC machine, an early one, but it was CNC nonetheless. It's got a 4 horsepower motor on it. That'll do, they both do the similar jobs. They just, I'm assuming, gave it more power because with the CNC, maybe you're going to load it harder, feed the stuff faster. I don't know the reasoning behind putting a bigger motor on it, but it had a pretty big motor to start because when you convert from 3-phase to single-phase, which I have to do because I don't have 3-phase power available, you have 2 choices. So my thought process on the mill is I have extra horsepower. I'm just going to run a phase converter. Now, what a phase converter does, if you can picture three-phase, picture you're a kid on the playground, and those little whirly things that you got, several kids powering it, and some kids get to ride. Let's say you got three kids equidistant around in thirds, and all three are pushing. That's three-phase power. Now, the phase converter, it fools the little wheel into thinking it has three guys pushing it until it gets going, and then it drops off one side, because with regular power, single phase, you got, two poles. So you got two guys pushing, and we fake a third one. And the machine's pretty happy, but it operates at 2/3 of its tagged rated horsepower. So do the math. If I had 4 horse, I'm going to take a third of that away. I'm still more than the Bridgeport, and it runs just fine. So I had one 3-phase machine converted. I was learning to use a mill, which, thank you, YouTube. That's how I learned to run it. And again, I still got all my fingers, so I haven't killed myself there either. But I'm wicked careful, because that thing would not hesitate to remove a couple digits. So another year goes by, and a buddy of mine and I get a deal on 2 Jet lathes. They're 2012s, about a $14,000 machine. We bought them from the local college, cheap. Picture the Jet over there. Now the Jet is imported. It's not as nice as my old American-made Logan back here, but it's bigger, and bigger means it'll do different things. I have bigger cutters on it. I made a bunch of cutters for it. I'll be talking about those probably in the next one, because I bought a bunch of carbides lately. I want to show you those. I make my own tooling. Again, thank you, YouTube. So I also, that Jet lathe has a pretty big motor on it. I think it's a 3.5 or 4. It's big again. So again, with a phase converter, I'm not sure how clear I was. A converter, you're only going to get 2/3 of the tagged or rated horsepower on the engine, on the motor. It's not an engine. I don't want to start that argument. On the motor, don't even get me going. All right, you just did. Mountain Motor, General Motors, Ford Motor Company. Motor, engine, doesn't matter. But in electrical stuff, I think it matters. It's not an engine, it's a motor. Noodle that for a while. So anyway, this gives you 2/3 power. The lathe had plenty of power. It works just fine on my converter. I picked up a grinder at an auction that was 3-phase. Got a wicked deal on it. It's huge. I like it. It's slow. It turns slow. About half the speed of a regular grinder. Now I got to mention that. Air compressors like the one behind me. If you buy a nice, expensive, quality air compressor, that's not. They turn at 1800 RPM. The cheap ones, like I have, they're loud because they turn at 3600 RPM. It's just like generators. The loud thrashers turn 3600. The expensive ones turn half that speed, makes them quieter. Back on subject. I've promised, and I will follow through someday, to go piece of equipment one by one and just do a brief description of why I have them and what they do. But this is a Kidder brand notcher, and they're made in Vermont. If it's sitting here, you know I got a wicked deal on it. This one really makes me happy. This thing has hardly ever been used. But it's hydraulic. It's got a big hydraulic ram, so that means it has an electric motor and a pump, and it's 3-phase. It will notch, due to its name, notch. These are guides. This whole 7x7 notch is what you can cut in sheet metal. You can go up to like 1/8 inch, probably 3/16 in aluminum. This thing's a beast. But when you start talking hydraulics, you need 100% all 3 phases or poles of your motor pulling their weight, or the magic smoke will come out of the motor. If you try to run this on a phase converter, you will smoke it. So I had to step up, do a little more research, and actually start manufacturing 3-phase power at home with my single-phase input. How does that work? Well, you got this magic box that's not real fancy. It's got some, things inside, but basically how it works is you have this three-phase idler motor that comes on when I turn on the phase converter, and it is making the third leg. It's taking single phase input with the magic box over there. It fools this thing into starting, just like the phase converter does. And with this running, it goes online, it goes back, and now it's got a third leg available for you to plug stuff into it. So now, and I will someday when I get more time, I'm going to probably wire from this over to the mill and the lathe, and I'll run them back on real three-phase power. I mean, they work fine the way they are. I don't have to. But someday when I have to be sitting on a pile of conduit and wire, because it takes pretty decent sized wire to run that stuff, I can actually convert back over. But for now, the only thing I got plugged into it is this Kidder Notcher. But it wasn't a huge investment to get it. In reality, for what I spent on three-phase converters, because the three pieces of equipment that I converted, with the phase converters, I spent half of what this thing costs. So it was not cheaper, and in the long run, it's going to cost me more. I should have bought this to start with. At first, I was just going to convert 1 mil. That phase converter was $100 and something, not a big deal. This whole rig here was like $820. And it'll run to size a phase converter, to size a rotary converter. Big difference. This is a rotary converter because the idler motor is rotating. And that's where your third phase comes from. You need to know your horsepower of the motor you want to run. Let's say this is a 5. That needs to be a 10. Pretty simple math. So if you add up all your motors. Now once one is running, once I start this machine, it takes a lot less to run than the next one. My grinder, that's the grinder that's three-phase, and the lathe and the mill, I could technically probably run them all if you started them one at a time. Let me expand on that one a little bit. This is my three-phase jet lathe. That's the converter. Pretty simple wiring. This machine has coolant, and it has a tiny three-phase electric pump. So small that I could not start it with that. That probably wouldn't even recognize it. But when I use the converter to fool my lathe into starting, the motor on this lathe is now manufacturing that third leg, and I can start my coolant pump with no damage to anything, and it works fine. It reminds me a lot of an episode of Green Acres where, never mind. She was trying to connect all the power. She had them all labeled, how many items she could run at once, like the toaster or lights, stuff like that. Well, it's kind of the same thing. Go back and watch the episode, have a good laugh, and you just gotta be careful what you're doing. So I start my lathe, and then I can start the coolant pump. I have to shut the coolant pump off first, and then I can stop the lathe. All this will be gone when I hook it into my rotary phase converter. All right, I should probably get to work. I've been working pretty diligently on the twin turbo Monte Carlo. I think I'm on like a 9 or a 10 day straight streak of working on it at least 3 hours a day. I worked on it both weekend days. It's coming. I'm down to plumbing, the fuel system, and wiring it. So that's not too bad. Yesterday I figured out the wastegates and the blow-off valve, plumbing, and vacuum for the transmission. That has a vacuum modulator on it, so I had to actually. Transgo makes a little blow-off valve thingy. For what it is, it's overpriced at like $28, but I bought the kit trying to just get the thing done. Basically, when it starts building boost, it lifts a little ball off its seat and lets off some of the pressure of the boost. You don't want to put boost down on the vacuum modulator. You don't typically see a vacuum-operated transmission behind a Turbo LS, probably. I don't know. But they make this rig, and now it's got one on it. So trying to figure out that, and I drilled and tapped. I show you, but it's up on the lift. The EVAP solenoid, ICT billet makes a nice little plug for that. I drilled and tapped that. Not much room to work there, but 1/8-inch pipe, so that's where my vacuum signal came from for my blow-off valve. And I plumbed my wastegates. and off the turbos. One step at a time. It'll be gone before I know it, and then life will open up. I can't wait to actually do more things on this channel. I started on the video I lost last time. I mean, I'm so itching to actually build stuff and not just talk about stuff. I mean, I build some stuff, but it's driving me nuts. I'm here to build stuff, but I got to get that car out of here. So soon enough. You guys have a great day. I've been picking up a lot of subscribers lately. It's awesome. I'm almost to 500, halfway to my goal of 1,000 and infinity and beyond. So keep it coming. I'll keep my end going. Thanks a lot. Talk to you soon. Bye.